Now we'll discuss potential energy stored in a spring. One thing you should always keep in mind, that is, force of an ideal spring. This is a conservative force in nature. That means whenever some work is done on a spring, or whenever some spring is deformed, we can simply state whatever work is done, it is stored in form of elastic potential energy. You can always write work done on a spring is always stored in form of elastic potential energy. Obviously, if it is being stored in form of elastic potential energy, it can be retrieved back. Like for a simple example. Say if there is a spring, which is right now in its natural length. One end of the spring is connected to wall, and other end is free. And there is a boy, who just holding this spring, which is a force constant K. Now say if boy starts pushing this spring inward, and say due to his push, boy compresses the spring inward, say by a distance x. So while pushing the spring inward, or while spring is being compressed, we can simply state boy was pushing it in and spring was applying a restoring force onto the block. Boy. In this situation, this restoring force will always be equal to the force applied by the boy, because the spring, which is ideal, considered to be massless. So we can simply state, as spring is massless, here, the force can be simply written as Kx. So if we calculate work done in compressing the spring by a distance x, work done in compression of spring by x, this work can be directly given as integration of Kx dot dx from 0 to x. Because here force depends on the position of boy, or force depends on the deformation in the spring. As it depends on the displacement, we have to use integration of f dx from 0 to x. You can see the result will be k is a constant, it is x square by 2. The result is half kx square. So this is the amount of work done in compression of spring by the boy. And as spring force is a conservative force, whatever work is boy has done, it is stored in form of potential energy, so we can simply state in natural length spring was relaxed. There was no energy stored in the spring, but in compressed state, spring is having some energy stored in it. We can simply state this half kx square is the potential energy stored in spring. Here we can simply state this energy can also be retrieved back. Now, the boy stops pushing the spring, and just take rest on this part of spring. We can simply state, spring is still applying the restoring force on boy, because of which boy will be displaced toward left. Now we can say, in the case of regaining the shape, or regaining the original shape of a spring, the compressed spring is doing work on boy, and boy will gain kinetic energy while sliding to the natural position. So we can state, while it was being compressed, boy was doing work, energy was being stored in the spring. While he'll release, and the spring is coming back to the original position. It was releasing potential energy and doing work on the boy, and boy was gaining kinetic energy. So we can say whenever a spring is deformed, it stores potential energy, and amount of potential energy is given as half kx square, which can be retrieved in doing mechanical work in any other process whenever spring will regain its shape. So far we have studied about compression of a spring. Whenever a spring is compressed, that stores energy. Similarly, we can say, if a spring is elongated, then also it stores energy. Because we know very well that during elongation also spring opposes the external force. And whenever opposition is done, gain of energy takes place because of negative work, so we can say, this stored energy will also be half kx square. In the spring, whenever some negative work is done on the spring in its elongation. So we can simply state, under deformed state. This deformed state may be compressed or elongated. In either of these cases, spring has some potential energy stored, and its amount is half kx square, where x is the amount of deformation, which is either compression or elongation. Using this energy, spring can also do work on other objects, like for example, say if in state there is a spring, of which one end is connected to a wall. And say we compressed the spring, by deformation x. And on the free end we place a block of mass m. Say if spring has a force constant k. And it is in a deformed state and its deformation is equal to x. That means initially the potential energy stored in the spring is half kx square, because initially the deformation in spring is x. So if it is deformed by distance x, it must be applying a restoring force on the block, that is kx. Obviously it'll exert the same force on wall also. Now due to this force, if ground is smooth, on releasing the block will start moving toward right. And we can say because of this force block will accelerate, will gain some speed, and you can say it'll gain some kinetic energy. When it'll be displaced by distance x, you can simply state in this situation block will gain some speed v, and when it'll be displaced by distance x, spring will be in its natural length, because earlier spring was deformed by x. So when spring is in natural length, we can simply state final potential energy of spring will be 0, and whole of the energy spring is supplied to the block. It has done work on the block in displacing by its own restoring force kx. So as block is being displaced in direction of this force kx, spring is supplying energy to the block, and in this situation we can say spring is doing work on block. That means spring is supplying energy. So we can say block gains kinetic energy. And in this situation, at this state, we can simply write by energy conservation the kinetic energy gained by the block must be exactly equal to the potential energy released by the spring, as initial energy was half kx square and final is 0. So the loss in potential energy of spring is gained by the block in form of kinetic energy. Using this relation, this half gets cancelled out, and directly you can get the speed of block, which can be written as root of k by m into x. Such type of many analysis and examples we are going to take up. But you must be very careful when analyzing potential energy stored in spring.